Hello everybody and welcome to Steam Republic's episode on decision trees. So this video basically is an introduction into decision trees, and before I go into the actual calculations of how you construct a decision tree from start to end, how you're going to solve it in your exams when you're given that question, I just want to go over a few concepts so that we actually understand what a decision tree is all about, how it works, and a few concepts that will help us understand how the calculations work and make it much easier, so that when we are in the test or an exam and if we forgot something, we can rely on this base knowledge to make our decisions going forward. As always, and I always mention this, is that when you have a strong foundational knowledge or strong knowledge of the basics, then the more tricky or technical parts become much easier. So in this video, I'm going to be basically tackling an introduction into decision trees, what it's all about, etc. If you want to jump straight into the calculations, you can view the other videos where I will be doing a few examples on how to calculate the decision trees in simple, straightforward and easy manners, tips and tricks along the way, and make it super simple for you guys. So the first thing you need to know is that a decision tree is a supervised learning technique, and for those computer science gurus out there, you know that supervised learning techniques is when the attribute or the outcomes of our data set, we know the outcome of the attribute or the outcomes of our target attribute. So for example, if I'm looking at something like whether I'm going to play sport today, my target attribute is called play sports and my outcomes is yes and no, and therefore supervised learning techniques will use that as my data. The second thing we need to know is what exactly is a decision tree. So a decision tree, essentially, it is a tree that is split up into basically leaves and decision nodes. And I should have mentioned it the other way around, because your leaf nodes are always at the bottom of the tree. So just imagine a picture of a tree. You have your root of your tree, which is at the bottom. It goes up, it then branches off. Those are your decisions, and then at the end is your leaves, and that is the actual decision that you make. So your branches or your decision nodes is where the decision that you take, and your leaves represent the final outcome. So if I'm gonna play sport today, yes, that'll be my leave, or no, that won't be my leave. So let's just show you a quick example of what a decision tree looks like. Right now, different people use different ways for representing leaves and stuff. I'm just going to be very simple and use my own. So for the cases of this here, decision nodes I'll represent with a square, and my leaves I will represent with circles. However, your teacher, your lecturer, the way that you do it, you should follow that sort of convention. So I'm going to say that make a first decision is sick. Right, and this can have two outcomes, yes or no. So either I am going to be sick or I'm not going to be sick. So if I am sick, then do I visit the doctor? And then we'll have another two decisions here we can make, yes or no. And if I visit the doctor, then he will give medication. Or if I don't visit the doctor, I will self-medicate. And then if I am not sick, I will go to school and be a good student. Okay, so this is basically an overview, a quick understanding of a decision tree. So simple things, simple concept, easy to understand, easy to interpret. You ask your first question at your root, am I sick? No. You will go to school. I am sick. Either I go to the doctor or I don't. If I visit the doctor, he will give me medication. If I don't, I will self-medicate. And that essentially represents a decision tree. Simple, easy to understand. Now, I'm going to go into the different types of decision trees. So we get two types of decision trees. And for the purposes of the course and for the purposes of students, I will be focusing mainly on the first type, which is number one, your classification. And classification deals with categorical variables or categorical outcomes. So these deals with things like yes or no answers or true and false answers. And your second type you get is your regression. Now regression deals with continuous data. So continuous data meaning numerical data, and these represents things like maybe my weight, but will it be but like between 50.5 kilos and 70 kilos. So this involves more numerical calculation, numerical analysis. But for the for the focus of this course, I'm going to be placing main focus on the classification decision trees. And what we need to know is that there have been a few algorithms that have been developed, but in the late 1900s, so that's the time near I was born, and I hope that I'm not giving my age away, we had the development of the ID3 algorithm. So the ID3 algorithm, and that's the most common algorithm that is being used up to date. And obviously you get some, you know, the budding researchers that's coming up with new algorithms, but we'll see how things form along the way. So yeah, ID3 algorithm, just for those that like to be pedantic about these things, is known as your iterative dichotomizer 3 algorithm. And what you need to know about this is, and I completely apologize if I pronounced this wrong or spelled this wrong in any way. So this was the algorithm that was developed, and we have two important concepts that come out from this algorithm, which is going to be important for us going into the calculation of the decision tree. So this is the part where you want to pay the most attention in this video. So your first concept is the concept of entropy, and entropy essentially is a measure of your randomness or uncertainty in your data. So quickly, let me say that I have a coin. So you know that a coin has a heads and a tails. So if I flip the coin, there's a 50% chance of me getting a tails, 50% chance of me getting a heads. So you can see there's some sort of uncertainty or randomness in the data. However, just say I give you a coin and it has two heads. Then the probability I get a heads, each flip will be 100%. So there's no uncertainty or no randomness in the data. So basically that's what entropy really measures. And entropy is represented by this. E of S, where S refers to your sample or your data, is equals to negative, very important to remember, summation P of I log 2, play nice, another emphasis on that, P of I. So important things to remember in this formula is the negative, because otherwise you will get wrong answers, and then the 2. So on default calculators, log normally puts it on 10. Now if you don't put log 2, you're going to be getting the wrong answer. So make sure that when you're doing the calculations, you use log 2. And P of I represents the probability of a choice. But we'll see how this formula works in the calculations. It becomes much easier to understand, because you know maths is really complicated. Right, now the second concept that I wanted to talk about is the concept of information gain. And basically what information gain is all about, and for those technical people, once again, this is known as the Kullback-Leibler divergence. And I don't know if I pronounce it right, and I'm not going to even think of spelling that, but it's the Kullback-Leibler divergence, and it is the effective change in entropy after deciding on an attribute. Now, that is extremely scientific for me, and I won't even bother about understanding the definition, but essentially it's a measure. It measures the relative change in your entropy with respect to independent variables. Sounds a bit complicated. When we do the calculation, I will make it simple, but it kind of is simple. So once you do the calculation, things will be much easier to understand. But all you need to know for now is that this formula is represented by information gain Tx is equals to entropy of T minus your entropy of Tx, where T is your target attribute, for example, place spot. X is your sort of normal attribute, and this is like, for example, weather. Is it hot? Is it cold? Is it rainy? Those sort of things. So I'm just gonna put this down, weather, and then place spot, and then we can sort of figure this out. But what I must place high emphasis or high importance on is the fact that you need to make sure that your notation is correct when you are doing a calculation. Otherwise, it does not make mathematical sense or statistical sense. And as a lecturer, as a scientist, as a researcher, as an academic, it wouldn't be deserving to give a student those marks. So make sure that your notation is correct when you are actually writing it out. But in the example, I'll cover this. Right, now quickly, we have the concepts known. Now let's go into the actual ID3 algorithm. And for this year, because the ID3 algorithm, it's actually sort of 7 steps, I'm just going to be quickly talking through them and not going through the full thing. But essentially, when we are doing the calculation, we are doing the ID3 algorithm in real life. And if you really want to code this, it would be good. Try it out in Java or Python, or I would suggest using Weka, which has it sort of pre-built. All you need to do is input in your data set. So literally, you can go and input any data set you want, and it will build a decision tree for you. So I recommend getting Weka as a good software tool to help you practice for exams, where you can make your own data sets, let it generate the tree, but don't look at the tree yet. You do the tree example, generate your own tree, and see what comes up. In some cases, there can be more than one decision tree that represents a specific data set. So back to the ID3 algorithm. So the first thing is you're going to create a root node for the tree. The second thing is that if all examples are positive, return it to the positive class. If all examples are negative, return it to the negative class. So this is basically referring to your leaves. The third part is that you calculate the entropy of the current state ES. So that's your data set, and you will see how all of this plays in the calculation. I know it sounds a bit complicated right now. And then the fourth step is that for each attribute, so for this is, for example, like for each whether what is like, is the moon out today, whatever attribute you want to call it, calculate the entropy of t with respect to x. So entropy of your target with respect to x. And then the next step is to select the attribute with maximum information gain. I'm just going to write step 6 and 7 here. And then your step 6 is then remove that attribute from your data set and sort of partition your data set to make your next decisions. And then the final step is to repeat until there's 2 conditions, and that is that there's only leaf nodes left in the tree, or there's no more attributes. So looking at this, you can already see that we have a for loop here, we have a repeat here, which is another loop. The complexity of decision trees are extremely high. That's what I was getting to, is that one of the major disadvantages with decision trees is that they have extremely high complexity. But there are ways to solve that, and you can use pre or post pruning. And just for the basis of this video, I'm not going to go into detail on that, but essentially you can use pre or post pruning to solve the complexity issue with decision trees. 2 good advantages of decision trees is that, number 1, they're easy to interpret. I mean, you saw the first example. I think even if you give this to like kids, they will be able to sort of put it together and understand what the decision tree is meaning. And then the second thing is that they're robust to noisy data, meaning that in certain instances, especially you'll see in the calculation that I'm going to do, there's situations where attributes which add no value to their data set will automatically disappear. So this is super cool concept of decision trees. So thank you for watching this video. I hope you enjoyed and learned some valuable takeaways. In the next video, we will be going through the actual calculation of the decision trees. So pop by and make sure that you watch that, and I'm guaranteed that you will understand that video. Very simple enough for you to go out to your exam and ace it. So catch you on the flip side, and be sure to like and subscribe.